everybody, and welcome to Strayos's webinar, FragR, Fragmentation AI in your pocket. Today we have presenting with us Daniel Castro. He is a solutions engineer at Strayos. My name is Kim. I am the general manager at Strayos, and I will be your moderator for today's webinar. A few quick housekeeping items before we start. We will be sending out a link of the recording of the webinar after the webinar has finished. Please keep an eye on your emails. If you gave us your email, you will get the recording, so you don't need to worry about reaching out to us or anything like that. If you would like a certificate, then you will have to reach out to us, and we can provide those as well. Also, keep an eye on your social media feeds. We post replays of the webinar summaries, and all kinds of other great stuff to LinkedIn within a few days after these webinars are finished. If you are having audio troubles, there is a dial-in function for the webinar. You can use your phone, and you can call the phone number, and you can get in that way. I will post the information in the chat box. If you have any questions for the speaker, for Danielle, while he is presenting, please put your questions in the question section of the webinar. Not the chat, the question section located over on the side. We'll go through those questions at the end, and if we run out of time, we will answer them in email form, nice, pretty written content, and we will shoot those emails out to everybody as well. Thank you very much for taking the time today to join Strayos's webinar. Daniel Castro, solutions engineer at Strayos. He's in charge of Europe, Africa, that whole set of time zones, located in Portugal. If you could please, Daniel, go ahead, take it away.
Thank you so much, Kim, for the introduction. Thank you, everyone, for joining our webinar. I hope everyone can listen me everything I say. I hope my audio is sounding good. And like Kim said, if you have any questions, please put it in the questionnaire section that we have here in our webinar. And after the presentation, we can discuss it. And if you have any questions, we'll have time to talk. It's not such a extent, it's not very big presentation, so I hope I can get your full attention for at least 20 minutes, 30 minutes, depends on how the flows goes. And so let me just change my slide. So welcome to FragR. Okay. It's always exciting to present FragR. It's such interesting new technology, and it's literally in our pockets, as the title says. It's super easy to use. It's a new kind of revolution that everyone right now, we all have a phone, we all have a dual camera phone. It's in everyone's pocket, the answer to maybe finally find the solution to fragmentation, at least for everyone's pockets. And how can you find an easy way to measure fragmentation, even if we don't have a drone or we don't have a tablets, okay? And a little bit of introduction to the company, to Strayos. We are right now present in more than 35 countries worldwide, using software, using FragR, or even the network camera that we have installed worldwide already, and for more than 5,000 mines and quarries. And that's why our AI, we have trained our AI into also different types of environments, from construction, quarry, and mining. So with different 170 customers. And of course, our global presence actually this year has increased because there was a need, of course, like Strayos is growing a lot. So we now have even global presence in Brazil, South America, in Europe, Germany, Portugal, Poland, in Asia, in India. So we are actually spreading through the world. If someone that is joining now the webinar doesn't know us, reach out, let's talk, and we are always ready to connect and to introduce our solutions. as just a little bit before we go into the fragmentation one, just an overall on the mine-to-mill process and how is it established and how we can also help. Especially on the mine, we work with the 3D photogrammetry engine. So we work with our drones, with LiDAR data, and we create our twin digitals. So we do survey and planning. Of course, then we have to go to next move. We go to the geology and to analysis of geology. Can be through rock mass, can be through lithology, can even be through measure while drilling. And then we enter the drilling side. In the drilling side, we can collect this data from the drilling machine, drilling rig, back to our twin digital, see what is our rock is. Through the drilling, we can then load our holes, choose the correct explosives, the correct loading, the correct timing. So we can simulate, we can create and predict muckpiles, we can predict dilution in a 3D way, and actually see if the blasting is occurring in a correct or not, and actually predict fragmentation. That is always a little bit difficult because, you know, the holes always deviate. You could use any device to measure deviation. And so it's a lot of things that it's always hard to predict fragmentation, but it's possible, of course. Then, of course, how can we measure fragmentation, right? And that's why we are here. And that's what we are going to discuss next. So talking into fragmentation for people that are not so familiar, how we usually measure fragmentation on site. We can do it through tablets, through the drones, and we take several photos. It can be a manual flight, can be a flight that we programmed before or even on site. But of course, sometimes, at least myself, when I was on site and I didn't have, sometimes like the other team is blasting other site and they have the drone. I don't have the drone with me, so I cannot do this. I cannot collect the data. Or sometimes we just need a fast answer. We want to say, look, the blast was good. We just need it on time, on the moment to collect data. And yeah, sometimes we can't. So what I kind of wanted to do in this webinar is kind of bring the field back to here. So it's kind of trying to do a mix of like being on the field and being also here. So AI and how we can measure where we can just take our phone, any phone, doesn't need to be a proper tablet. Without connection to internet, only for internet. The only thing we need is full camera, 24-hour muckpile, and yeah. I think our video the sound is not very well, but it's okay. You got what the purpose is. We are here to talk about AI and of course tiny AI more specific. So our agenda for today, it's the role of tiny AI in mining operations first. Then we go into the technical breakdown and how the smartphone-based image segmentation works. Talk a little bit about the accuracy and performance of AI-driven in fragmentation analysis, and then we will talk a little bit about use cases, the result from the field, and I have a little bit of a demo, also like steps, like how the steps work in the app, and then of course we have time for questions. We will get there. So welcome to Tiny AI. I'll kind of go first in a little bit on why fragmentation, of course, matters, and what is the direct impact on having poor fragmentation or having a very high coarse size or a lot of fines. So of course the direct impact is always on the crusher throughput and of course the milling efficiency. So what we feed the crusher, it will influence, of course, all the process. So it's like it's kind of a blockchain. So if we start, if the beginning, the first thing is the fragmentation, is the blasting. If we already start this beginning of the blockchain in a not correct way, it will already ruin all the yield, like I mentioned, the throughput. And of course, poor fragmentation will influence the fuel consumption, the machinery wear, and of course, the opposite, a better fragmentation can optimize all the costs and improve the production rates. So what is the key for this? How can we solve this? So how can we optimize fragmentation? And this is a balancing act. So the key is to match all the requirements from the plant. So we have a size that we have a limit from the minimum to the maximum that we want to reach. And if we are not measuring it, how do we know what we are feeding the crusher? We know the limits of the crusher, but we don't know what we are feeding it. Okay, without measuring fragmentation, we can visualize and say, yeah, this rock will fit. Or sometimes we just don't have time to process a 3D module on time while we are already feeding the crusher. So at least on the coarser fragmentation, when we have coarser fragmentation, of course, we will decrease the throughput rate, increase liner and the grinding media consumption, and secondary breakage. Of course, if we have finer fragmentation, this means that we also have drilled too much. We have increased our blasting cost too much, and of course, we yield loss from fines. So once we measure fragmentation, we will get these results. So the famous values of D10, D50, D80 that we always use to measure fines, or to measure the 50% of passing material, or D80 to measure our boulders. How we have these rocks that always influence the secondary breakage, if we have to do it or not. So what we have to do, we have to be on our target zone. We know that those are the limits that we need to be inside. But we can only know if we are between our targets if we measure fragmentation. If we don't measure, sometimes we cannot even evaluate. If we are working with a contractor that are blasting for our plant, how can I know if they are doing the correct job or not? So it's also a way of evaluating a contractor it's doing the blasts in the correct way, if everything is working perfectly, and if we are actually on our target zone. That is the most important part. So we can have an optimal crush feed. So I have another video. I'm not sure if you'll listen. So what I mean is, like, should we measure with tape? Should we, like, once we want to measure fragmentation and we don't have a scale, every time we have to go there, a professional needs to be doing this type of work. And what we want to do, instead of having all of these expensive tools, just a standard smartphone that is already on site. It can be from the blaster, it can be from the driller, it can be from the driver from the excavator. Anyone that has a smartphone can measure it. That's the big difference. That's the big goal. Not having scale objects to the different scales on fragmentation. Just a dual length smartphone that has deep sensing will be enough. The AI will detect all the rock planes, and like I mentioned, any team can be doing the job. And of course, the results, I said that they are available in minutes, but I think once I show you the demo, that will be under 1 minute. You have results. So everything that I have done, like recording a demo, I just recorded my own personal phone. So I didn't even edit it. So just like reality. That's what I kind of want to show here. And so I even want to bring a little bit of the field, but since it's not working the sound so well, it's no problem. So higher sampling, we can take much more photos and take much more samples. And of course, working during dust, and the weather is changing, or if it starts raining and I cannot fly my drone, I have at least a way of measuring. Now I can continue my work. It's not the weather that's going to see, it's not as an excuse using the weather to not do the job, to not make it happen. And of course, this data, I think I haven't mentioned, but we don't need the internet. I think I mentioned, but it's okay. What I want to say is we can keep everything offline, and we can just take your PDFs, take your CSVs, or we can actually connect to the Strayos platform where we have our drillings, all our work, and where is our data center. we can actually push this data back to Strayos if you want. Or if not, we can just keep using the phone as the user prefers. So what I wanted to say here is like, this is not about replacing fragmentation analysis, it's about removing friction so measurement happens more often. So let's go a little bit more deep into AI. So this looks like whoa, such a lot of information. What is this? I know, like talking about AI, it's always a little bit complicated sometimes, but this is actually what we have in our phone, what we have in FragR is lightweight AI. So we actually want to turn this all complex neural network that we have. So as you see in the image, it's like a cone, and we are getting down the cone. So with this lightweight AI, we are going to turn all of this information, all of this neural network, and getting it smaller with fusion. So all the mathematical equations, we're going to mix them. We're going to make a fusion of them, so we have less. Or you can use pruning. So this will be using less numbers of neurons. So it's like our brain, if there is neurons that are just occupying space, and the connections are not being actually done, so they are just there occupying space. We don't need, they are not being needed for these complex equations that we are working. We will cut them and not being using them, so we can have less memory. And of course also using quantization. So this will be using less bits. So instead of working as like 32 bits, we will work at 8 bits. So everything so it could fit in our smartphone. Instead of having a huge data center with needing to be on a cloud system, we want it to be on the device, right? So the key feature of Tiny AI for rock segmentation in this case is on-device processing. So no need to send any data to the cloud to be processed. Tiny AI allows the rock segmentation algorithms to be run directly on our mobile devices. So as I mentioned, eliminating the need for cloud processing. Real-time analysis. So this means that I go to the field, I finish my blast, I just go there and check if everything is correct, if all my explosives was detonated, if everything is okay. At the same time, I'm taking a photo with my phone. I don't need scales, and in 1 minute I have the results. Of course, if I want to take more photos and join them all together into a big fragmentation curve, I can. Of course, reduce energy consumption, because these modules will not take all our phone battery away. So it's built in order to work okay and not kill our battery in one time. And of course, we are enhancing privacy and security, because all the processing is being done in a local place. So all the data stays in your phone. If you don't want to send anything to the cloud, you don't have to, because everything is done offline. So what are the differences between Tiny AI and traditional AI? I've already kind of been explaining, but just so you can, the perfect example is once you install FragR, the only thing you need internet. I can already give you a few examples on the only thing we need the connection. So if you install the app in the app store, the only thing you need is to download our AI. And usually any AI that we have in the big network systems, they have gigabytes and like huge. But what we have done is create our AI is only 200 megabytes. That's the only space it will be covering from your phone, and you just need to install this AI in the phone, and we are ready to go to the field, ready to take any pictures and just work. So compression techniques, this is talking a little bit more about technical in the AI, so new words. So something called knowledge distillation. This is having a big model like we have the first fragmentation module and turning it into, so the big model is teaching a small module. So we have network pruning. So it's trimming the narrow network. That was what I explained before, like cutting a little bit of the connections that are not being made. They are just occupying space. So we are taking those away. So we have more space, more memory. And of course, quantization. That is what I mentioned also before, going from 32 bits, an example, to 8 bits. And with this, we are also able to optimize memory use using tensor spilling, fuse fetching. So these are also AI techniques that we have been using to reduce peak memory up to 39%. So let's go really into the app. So we already talked about fragmentation, we already talked about the Tiny AI. So let's go about the technical overview of FragR. So now we are mentioning the app itself. What we need to do is set up data capture with a smartphone. We just need to have a smartphone equipped with AI-driven LiDAR, or even as standard depth sensors. Of course, just to people be aware, a pro device is always something that it will behave better because of the AI-driven LiDAR. Pro devices that's why they are more expensive also, but they also help a much better analysis. Just a heads up, so people who want to try at home. AI-based segmentation of images. So we are capturing the images using convolutional neural networks and modules to optimize in the device processing. So Tiny AI will identify all the rocks based on the shape, texture, and size. The step 3 is measuring fragmentation sizes. So the module will apply the spatial deep estimation. As you see in the photo, it will not be a 2D perspective, a common 2D visualization, but will be a 3D one. And then, of course, the real-time feedback and analysis. On site, on the same moment, we'll have the percentage of finds, the distribution, fragmentation size distribution, and of course, the oversize detection. So basically, we will have access to the D10, D50, D80, and of course, have our distribution curve. And in the moment, we can just send reports or just download PDFs or just look at our fragmentation curve. So right now, as a quick demo on how we can measure. So this was actually from an Android phone. I didn't even use the iPhone actually for this one. So Android or iPhone, it's okay. We will detect our plane, and we just have to select 2 points. I don't know if you see 2 red points, and the software automatically scales through the plane, and it already knows that these 2 points, without me putting any scale, is 1.3 meters. And it's going to use the deep sensors and the distance between these 2 points also to know the size of the rock. Okay, it will identify every little rock, and then we just have to choose polygon through the area that we want to analyze. Once we finish with the polygon, we click yes, we process. It takes less, I think it took under than 1 minute, and I already have the results. I can just click size distribution graph. I could already do a PDF report, send it straight to my team that is blessing in the other side. A little bit. I want to have this in explaining this because I'm going to send you the PowerPoint so you can have it. So you can also use it as kind of a how to work. So as you see at the step 1 floor plan, we will move our phone and point to the area that we want to analyze. It will build the plan, and after the plan, we will select the 2 points. So with our fingers, we select 2 different points, and you see on the back, it's already identifying in blue points. And we also have the 3D data quality, that if it is very low, this means that we are too far away. We have to go closer. So we kind of use this as a distance if we are too close, too far away from the pile. Then we take the photo, we select the photo we want to analyze. We just create our polygon with our fingers. We select the area we want to use. Then we'll have the processing, takes few seconds, and we'll be already able to see the graphic view, and of course do any reporting such as size distribution graph, the fragmentation report, and of course the chart range. Then a few things that we have added to the software is, so we take different photos in different areas of the pile. We just click on select button. We select all the photos from that we took that we want to merge into one. Okay, we just click on merge, and it will give us the size distribution graph from all of the photos that we selected. Right now, what I did, I selected only 3 of them, and I merged them into a size distribution graph. Of course, as you see, we have a sync button that if you are a user of Strayos software, we can sync it as a project back to Strayos. And now a few tips and tricks. I also had the video, but I think we can't listen very well, but I can mention. It's just, of course, as I mentioned, be 4-6 meters away from the pile. Pay attention to the good 3D data. So the bar that we have on top, if it is too small, or if the perfect is if it is all full, of course. Have the floor plan well detected, because sometimes the azimuth might be a little bit off crooked, or it can be in the not well. So move a little bit the phone to one side, to down, top, so the AI can detect it better. As I mentioned, pro devices work a little bit better, but the not pro device can also work, especially on the Android. And of course, I mentioned that it's prepared to avoid shadows, but at the same time, we as the user should also not be taking on purpose a photo on a shadow. It's much better to work with the daylight when it's I won't say it's sunny, but at least at midday that we have less shadows, because the sun is on top of us, so it's not like at 5 p.m. that we have a lot of shadows in the rocks. It can influence the results, but the AI, it's trained and it was modeling not to. Okay, just it's always good to avoid. And a little bit of tricks I already mentioned. Don't move the camera after selecting the 2 points. Very important. Once we select the 2 points, we are scaling it, okay? But it's automatically. But if we move the camera, the scale, it will not be matching. So once we click, we have the 2 clicks and we do the scale, we just take the photo and we can take it on the side, as I mentioned here, so we can have a better range. And of course, we can join different photos into one final analysis. The accuracy level of the analysis we have tested with LiDAR-based systems, and it can vary from 1 to 2%, making it very high reliable. Reduction in error rates, so the AI is trained to recognize irregular shapes and shadows, as I mentioned before. And what are the benefits being on a device AI? It's not the cloud, it's on the device. This latency-free analysis, so the results are instant and we don't have the cloud processing. I'm not saying it's bad having cloud processing, I'm just saying it's instant right now, because we also do it on cloud fragmentation with drone. We have, if it is a huge muckpile and there are areas that is not safe to go with the device, we use the drone. This is for in cases that we don't have the drone and we have to do it on the field and we wanted to do it fast. And of course, privacy and data security, since we are doing it on the phone. And the field tests and validations. So the results from trials, we have been working in several quarries and several mines, and we show a significant reduction of oversized materials when they use tiny AI analysis. And the average of savings that we have, it's a reduction of downtime, material handling, and the contribution for 5 to 10% of operational efficiency improvements. Then where are the key use case and benefits? So of course, pre and post blast comparisons. We evaluate fragmentation changes so we can adjust the blasting patterns accordingly. Crusher feed optimization, real-time size distribution analysis helps operation fine-tune the size, improving crush performance. So we already have 2 different things where we can use the fragmentation and the values to improve the blast and also to improve the crusher performance. So we already are saving a lot of money here. Cost-effective fragmentation monitoring. So no need for specialized cameras, as I mentioned, or software. We are using our phone. And we have safer operations because we don't need to bring extra people to do it. The people that are already in the field can do it in their own phones. And of course, I want to share some results from the case studies that we have done. This is when we start in the quarry in the North America. They were using also the tiny. So this is not from a drone or from software. It's from our AI in our phone. We have the outcomes of 30% reductions in oversized materials post blasting. Crusher throughput increased 8%. We have savings up to $50,000 in operation costs over only 6 months. And of course, I think everyone that have used any software have tried to improve fragmentation. This is not a one-time thing. This is something that takes a few times to adjust. We will not adjust the best throughput in our crushing in one time, in one analysis. This is something that it needs to be part of the daily job, of the work, and the results will come with time. You know, it's like learning guitar. You will not get a guitar and learn it in one day. It's just it's not the best comparison, but just so we can kind of understand. And of course, faster decision making. I've been myself in the field, and I was like, oh man, it's now I have to fly the drone again, and then I have to go back to the office, and I still have to process, and then it's already off my daily day, so I can only see the results tomorrow. You know, so sometimes it takes time. So the year we have in minutes is what we can generate results in minutes instead of in hours. That's the big difference. So some different ways I think it's also about being creative in FragR. You know, like I've been testing in normal quarry and mine muckpiles. I've been also trying to introduce it into construction and rock armors. I have also tried to use it in after the crusher in stockpiles, and actually off-record tests, so we can have a little bit more. It's all about creativity, you know, like be creative. Who knows? Maybe FragR one day will be used for the food, for measuring shells on the beach. I don't know. Like it's about being creative, and it's in your phone. You know, you can just be on the weekend and it's like, yeah, I'm gonna test FragR. I'm gonna use it here. It's an app, so just use it. And of course, for conclusions and key takeaways, 𝗬𝗨 transforms fragmentation analysis, making it faster, of course, more affordable and more accessible. This is a huge difference, I think, being much more affordable. And I think once you want to know, you can talk later. Accurate on device results. So despite we are having our own phone device, it's super accurate. And we have already like proven results. Is a smartphone-based segmentations. And the results: improved throughput, lower costs, and safer operations, all driven by the power of 𝗬𝗨. And I hope you guys, I told you it was not going to be like a huge presentation, huge webinar, just kind of talk of different topics, talk about AI, 𝗬𝗨, all of these different, different things that we have mentioned that are new concepts, I think, for all of us, AI. And let's see what the future brings us, right? What technology brings. And yeah, I terminate my webinar now. So I think I don't know if there is any questions. Thank you so much for attending. And I hope you learned something today with me. I mentioned before on LinkedIn, anyone that wants to try it for free, like just contact us. We can create any license for free, like 1 month or the time you need to try it. And please, if you attend the webinar, you have access to this. Don't forget. So Kim, if I'm all done here, thank you.
Thank you very much, Daniel. We appreciate it. That was fun. Sorry for the little bit of the technical issues, but
we always have.
We live and we learn, right? At least
Exactly.
It wasn't Strayos.
Nah. This was me. It was my videos that were like, yeah.
Well, we can definitely figure out how to address that problem, that issue in the future. I do have a couple questions for you, real. Have you done?
I think I can hear you very well, but yeah, let's go now.
Okay. Have you done any statistical comparisons between this mini AI and the use of a drone?
Yes, actually, that's why I went to these sites. Like the first site that I actually shown you, because it's a very controlled environment, and I actually know it was actually from a quarry that I was blasting. So we actually were blasting for the seafront, so we know the sizes of the rock. We actually know the sizes of the rock because it was for construction, and only these sizes of rock were actually used. So yes, I've been doing that. I've been going to that specific site. I have flew the drone, and I'm also using the AI for FragR, and it's very similar. Exactly. I think I have probably the difference. It can be up to 5%, 4%. Of course, the drone is also taking. Is going to. The only thing is that the drone is taking a little bit more area that I cannot reach with my phone. So I can't be also. Some areas I didn't took the photo with the phone, of course. That's the only, I think, difficulty. Maybe it's some areas that we just cannot reach. That's why the drone always has that power.
Does the same login work for FragR as for the Strayos platform?
Exactly. Yes. You just have to. So if you're already using Strayos, talk with the team and say, hey, I would like to try FragR, and we just add you the module, and the same login will be the same as FragR. And like I mentioned before, we can sync data. That's why it's the same login. All the data that we are measuring, we can actually send it back to Strayos, to the software. So yes, the answer is yes.
Okay. If a customer doesn't need constant access to the entire Strayos platform, can they purchase FragR by itself as a standalone tool with a smaller subscription, or do they need to buy the larger software suite?
No, not at all. Already inside of the software, we already divide the software through modules. So some people just use fragmentation, some people just use drill and blast, some people just use geotechnical tools. FragR is the same. FragR is a standalone option that you can just talk with us, and it's a small subscription for the app, and that's it. There's no need to use Strayos at all, just the FragR.
And then I think we addressed this last question already earlier. What is the accuracy rating of FragR?
Yeah, exactly. So we have compared with the actual laser devices, and the difference was between 1% to 2% to 3%. I have compared with the drone analysis, and it was up to 4%, 5% difference. But at the same time, I could not take all the photos with the phone, to all the areas. So it's always a little bit tricky to answer. But between those are the ranges that I have get myself.
Yeah, and FragR has other very good benefits. Maybe not getting the top of the muckpile, but being able to get a picture whenever you need it, multiple pictures while digging. Whatever.
Exactly. While digging, that's wow, nice, Kim. That was a good. I didn't address that one.
Yeah. So you can get more data from underneath as it's cleared away without having to wait for a drone too. All right, Danielle, couple more questions. What is the average processing time per image on a standard smartphone?
Yeah, it's less than a minute. It's I kind of gave the demo before, and this is actually recorded from my phone, so without actually editing. And now it's not showing. Okay, so this was between I don't think I have the time. So this was 1 minute actually. So I just look at the floor, take the scale, then after we choose the polygon, it's kind of it's super fast. It's a few seconds, and we extract the edges, and that's it. It's as simple as that. Of course, if you want to take more photos, we just go to the other place, we take another photo, then we merge the photos together. All of these, if we take 4 or 5 photos, will be under 10 minutes, 15 minutes maximum, taking all of these photos and process all of it. Just one, it takes 1 minute. Then it's just moving to another place to take another area.
Does the quality of the phone matter?
It matters only if it is a pro device. It has an AI deep senses a little bit better, which will be will analyze a little bit better, at least when we're talking about the deepness. So also talking about the quality of, not the quality of the edges of the rock, but the size itself. So imagine any Pro device works amazing. I've worked with Android like a Xiaomi 13 and it worked well. I've seen Samsung working really well. I've seen like an iPhone 13 without being a Pro, sometimes struggling a little bit, but any iPhone that is a Pro device, it works pretty well. It's about testing. I haven't tested with all the phones, you know. So I think every brand will be a little bit different. That's why we also accept a lot of feedback. And anyone that wants to use it, we are really happy to share with you free logins, so you can see if we can improve your operation also. And also we help together as a developing team.
Do you know how many megapixels the phone needs to be to get that accurate data?
Talking about megapixel data, photos, I actually don't know the number, but any like phone that with 3-4 years, I already have a dual camera and that has the normal like 24 megapixels maybe. I think every phone that is recently, like at least 2-3 years, 4 years of existence will work 100%.
Okay. I will answer the next question, and if you have anything to add to it, feel free. Are there any regions the app is not available in? As we are a US-based company, the answer is going to be unavailable for countries and regions that are under a US embargo. That's about it. Do you know of anything beyond that, Danielle?
No, I think you answered okay.
Yeah. Let's see, can you take pictures as they... yeah, we addressed this one briefly. Can you take pictures as they muck the pile and get better data? So while digging.
Exactly. We can also take pictures while digging, and then we can merge all of the pictures in the end into a final fragmentation curve. So if you want to take 1, 2, 3 pictures before digging, and then while digging, you take again the pictures just to have what's inside of the muckpile that for sure will be different. We can, and it's such a good work to do if you have the time. If the person that is operating the excavator can be doing this job also, because he also has a phone, and he just needs to have the app, and he can also do that job.
How deep does FragR measure into the muck pile with a single photo? Or simple photo?
So as I mentioned, if it is a Pro device, for sure it will go further. So we staying 4 meters from the pile. Like in this example, I choose until half of this pile. I could even go further. I'll say up to I don't have an exact number actually for this. I think this is I don't have. Maybe I could try to find a number, because right now I don't want to say like a wrong number, like how deep we can go. But it's gonna depend a little bit. If we are talking about deepness of the photo, it will depend if it is a Pro device or not, like I already mentioned before. That's 100% sure.
Are you referring to how far away you need to be from the muck pile, or how deep into the pile the phone will?
Exactly. I'm meaning how deep into the pile it can go. Sorry. How deep it can go into the pile. It's gonna be if it is a Pro device or not.
Okay. Let's see. Next question. Oh, what does the R in FragR stand for? It doesn't stand for anything. It just sounded good. Unless you know different.
Wow. Elevation R. Frag elevation R. Just sounds cool, you know.
Yeah, just sounded good.
Like everyone in Strayos, we have to be cool. So no, I actually don't have an answer for that. Sorry.
No, I'm pretty sure it's just because it sounds good. Like I am like 90% sure that's why that's there. Don't want to have a boring product name. We have too many of those already.
So that's actually a good question. Do we have more questions?
Yeah, I got like a ridiculous number of questions here. They just keep coming. I can barely keep up. The architecture might be better for a written answer. Do you know what
go ahead.
Would an iPhone 14 Pro Max be okay?
Yes, it will. Yeah, mine is iPhone. I have, this one is not even a Pro device. I'm actually this video. So iPhone 14 Pro Max, it's amazing already. Especially because it's even Max, so it's 100% functional.
Mm-hmm. Can you merge the drone fragmentation after the shot with the photos throughout the shot?
Whoa. I actually am not 100% sure. I know that we can I only have been syncing it to Strayos. So if in Strayos after we have a fragmentation analysis, I think maybe I haven't done it. I have to be honest myself, since I haven't went through 100% of this. Maybe it's something that we can discuss this later, maybe, or like it's something that we are probably developing.
That's a great question to check your email for. As I said, we will be answering all of these questions in written form after the webinar and sending that out as part of a webinar summary. And when we send those out, those answers will be aggregated across the team. So you will get the best possible answer based on everybody's particular expertise. I don't know why you can't find the app in the Google Store. Try again. It's there.
Yeah, it's App Store. It's there. FragR, like with R, like this. Maybe you have to scroll a little bit, and it's in the App Store. It's in the Google Store for Android, for iPhone. Even if you have to scroll a little bit, since we don't have many downloads for now, it won't show up in the first in the beginning. Maybe I can go to my phone and see App Store, but we can continue.
Okay. All right. Can FragR be used underground?
So yeah, that's something that I've been. So just by the way, I cannot show. I'm not sure if my camera is being shown, but it is as Strayos FragR. Okay, so it's not just FragR. It's Strayos space FragR. Okay. What was the question? Sorry.
Oh, can FragR be used underground?
Imagine. I wanted to do a few trials on that, and that I've been talking with a few people that are trying right now, and it's something that I believe yes. It's all about lighting.
Yeah.
Having proper.
I was gonna say as long as your lighting conditions are good enough.
Exactly.
And that would be the largest challenge underground. How the data is secured and give photo to AI. The AI that we give these photos to is our AI. It is not a third-party AI. It's not one of the LLMs like Chat or Gemini or Claude. This doesn't go anywhere near them. This is an AI that Strayos built in-house and that we have been building for over 10 years. So Strayos AI is actually older than a lot of the AI companies that are coming out, that have come out since Chat launched in, when did it launch? 2022?
Maybe,
I don't know. Something like that. But Strayos actually predates all of the LLMs. We have our AI is based on computer vision and not a large language model. So we don't give your photo to any AIs for processing. It's entirely in-house. And we take we take security very seriously here at Strayos. So you don't need to worry about that. Okay, so we already discussed the accuracy. When you get a photo, no, you don't need to put a scale.
No.
Could
I
it be
mentioned, yeah.
could it be extended in the future into, oh, I guess this is like a development plan.
Okay.
Okay, so as far as development goes, if you take a video of the muckpile,
Oh,
now we're getting closer to 𝗬𝗏. That's more of a 𝗬𝗏 question. If you take a video of your muckpile, will we get this? Should we talk about 𝗬𝗏 instead?
I would say, yeah, I think a 𝗬𝗏, it's a camera that's it's almost video exactly, but I would say like if the phone's improving to a like if we can do a video like in a laser format, last file, and it turns, because I think right now we can do a video around the pile, like a stock pile with a phone, and it turns into a last file. And I don't know, maybe in the future from that last file, we can also do fragmentation in the software itself. I won't say in the phone. It's more like also like software and to nature at the same time, you know? But yeah, we are here to build the future as Strayos. We are a developing company. So we are always like developing new products, new features. This app right now, if we do it another session in 1 year, it's going to be with 3 or 4 more new capabilities, totally different. It's the same as in the software, as in 𝗬𝗏. It doesn't stop the development in Strayos. So yes, that can be possible one day.
Yeah, not just possible, likely. It's pretty likely.
Yeah, pretty likely to be possible.
Yeah, we already have a if you don't know, we already have the 𝗬𝗏 camera, which does fragmentation processing in real time. The hardware is a bit different. It's not in your phone. It's an external edge device. So processing video might depend a little bit more on the capabilities of the device as opposed to analyzing pictures. But I can promise you that if we get enough requests, that'll be one of the first things we look at. That'll be one of the things we look at in the near future. Sometimes getting fragmentations at crushers might be easier that way. Yeah, I think we're back to 𝗬𝗏. If you want to get fragmentation at your crusher, you need to come for one of the 𝗬𝗏 webinars.
Actually, I thought about this. Like, imagine having someone. This is another level. Like, if you have someone near the crusher taking the photo through the phone to the truck before they dump into the crusher. Maybe one day we can actually develop that in the phone. I already tried that. I already tried measuring in the conveyor belt while running. I already tried to measure while dumping in the crusher, but it's something that is not developed for that. It's just like trying like error and trying. So maybe I think maybe it will actually be working in the future. That, but it came from, it already crossed my mind that idea.
All right. Let's see the next question. Wow, they just keep coming. Jesus Christ, Danielle, you're super popular.
No,
all right.
not.
You get
Someone asked me like a philosophy question. I can also answer those.
Let's see. I'm trying to simplify this question a little bit. Do you get or need a photo or video, or at least a narrative of the blast to include for analysis with the final fragment analysis? So all right. If you use Strayos to plan your blast, yes, you will have the blast design, you will have the blast loading, you will get the blast report, the fragmentation will come out. There's all kinds of documentation along the way. And if you sync FragR with Strayos, you get all of that. I think the question is asking, if you use FragR by itself, do you still get a narrative of the blast with the final fragmentation analysis?
No, I think not. That not a narrative, just raw data. Let's say the sieve curve, the report, but not like a narrative of the blast before. No, I would say no. I think this is kind of the question that I think we can also discuss later.
Yeah, that's something we can expand on in the written answers. As far as taking photos of misfires and bad blasts, that's always recommended practice. You can identify a lot of problems with a blast if you're taking videos of the blast. We actually had a guest lecturer a while ago discuss the benefits of taking videos of your blast and analyzing it after the fact. So while that's not necessarily a Strayos thing, we do recommend, that's always a good idea just to have more data so that you can look at your blast from a different perspective. All right, somebody's trying it underground. Good job. Go for it.
Yeah.
We love it when customers bring us use cases we don't necessarily plan for. You would be very surprised how often, or maybe you wouldn't be surprised how often people come to us and tell us new ways they've used our tools and our software. Happens all the time.
That's when I mentioned before, like, be creative, Sometimes people, I think a lot of times I get taught by the users, like from different types of, every site is different. Everyone finds different way of using. I say, be creative. Like I was trying on peanuts. Why not? Like just creativity is amazing, like never stop being creative. Yeah, please that.
I agree.
That's my final message of the webinar. Never stop being creative.
All right. We got a clarification. I mean, more of a small video while a truck is dumping into the crusher. You need to talk to, you want Netra. If you're trying to get, that's Netra, straight out. If you're looking to get real-time fragmentation analysis of your entire load while the truck is dumping into a crusher, that's Netra. That's not really FragR. We have at least one webinar, maybe 2 webinars on Netra specifically on our YouTube channel, where you can go take a look at that. Alternatively, if you want more information on Netra, you can contact Strayos or Danielle. And that's really what you're talking about.
Yeah.
Let's see. Do you pay to use FragR? Yeah, because nothing in this world is free. It's a lot smaller than the Strayos, but yes, you pay for it. Is there a certification? Only if you email us. If you want a certificate of attendance, we will email you a certification, but you got to ask it for us. We don't just send them out. Could I use FragR to photograph a recently excavated wall and use it to determine in situ block size?
I think probably yes. I think this is I can imagine this. I never done it. Again, creativity, and I think this might actually work. If it is, I think something that for sure, if you want to try, you could. I think it might actually work.
Yeah, give it a try. Let's find out.
What level of integrations you guys have? Okay, please, Kim. Sorry, I'm stealing your spotlight now.
Wait, yeah, shut up. This is all I get to do, Danielle. Just read questions. All right.
You are answering a lot of questions. Thank you.
You're welcome. What level of integrations do you guys have with all the technologies available? Can I plan, do, check a blast, and after that, make the fragmentation analysis and upload the results on this planning software again? Oh, such a great question.
Do you want to talk about API?
You want to talk about Miningindustry?
Miningindustry. Last question. I can pop up another presentation so we can talk. No. Yes,
yeah,
we can. We don't need integrations with Strayos. We can actually do photogrammetry, create our 3D from the drones. We have APIs with the dock station. The dock flies alone, goes back alone to the drone, goes back to the dock. We have API already with flight base. The photos go straight to Strayos automatically. We start processing automatically. At the same time, we have AIs trained to be identified during the processing of photogrammetry. So the muckpile will be already identified. The fragmentation is the same. So we can actually measure without human touch fragmentation. Because if the dock is already flying, coming back alone, processing automatically, The AI is also identifying the muckpile, and also the fragmentation is done with AI. And everything is in Strayos. Again, the drill and blast is also done in Strayos. We can actually pull the two together, so we can actually see fragmentation and actually see the holes that we previous blast in the 3D module of the fragmentation. So yes, everything is connected in one platform called Strayos. And of course, like all the geotechnical analysis we can also do, rock mass, we can do it in Strayos. Measure while drilling, everything is in the same platform. No other softwares, no other like how do we call, like I'm missing the word, like a third party. Yeah, everything that we have presented and we present about Strayos is built by us, done by us, same as Netra, the fragmentation camera that we could kind of record the video of the dumping material. Yeah, I think this was the last question. No, I think
it is.
Yeah.
I do want to mention a couple integrations that we do have also. Smart drill data. So if you have data coming from your smart drills, from your bore track devices, you can upload all of that into your Strayos 3D model, and that can supplement your blast design. And then it can also help the Strayos predict your fragmentation that you can compare to your actual fragmentation via drone flight. And then other technologies, we integrate seismographs and send them. We will have written answers to all of these questions that we will send out to everybody who has attended this webinar. And since that is the last question, then in that case, I will say goodbye to everybody. Have a great day, and we will see you at the next one, which will be on haul roads, I believe. So if you're interested in the Strayos site analytics and some of the really amazing developments that we've been putting into our haul road AI, please sign up for that one, because there's some really great stuff coming down the pike.